Welcome to This Explainer. Today, we are going to explore a mathematical mystery that honestly totally breaks human intuition about probability. It's famously known as the birthday paradox. And well, by the time we wrap this up, you'll see exactly why our brains are just wonderfully terrible at grasping large numbers. So, let's jump right in.
All right, I want you to imagine something for a second. You walk into a room, look around, and there are exactly 23 people standing there. Not a massive crowd, right? Just a, medium-sized gathering. Ask yourself right now, what do you think the odds are that two people in that exact group share the exact same birthday?
If you're like most people, you'd probably instinctively guess that the chances are incredibly low. Maybe you're thinking, I don't know, a 1 or 2% chance. And honestly, guessing that low is completely reasonable. I mean, there are 365 days in a year and only 23 people in the room. Why wouldn't the odds be tiny? Well, prepare to be a little shocked. The actual odds of a matched birthday in that small room are greater than 50%. Yeah, no way, right? You literally have better odds of finding a birthday twin in that room than correctly calling a coin flip. It sounds like an impossible coincidence.
Okay, let's dive into this. To understand why this feels so deeply wrong to us, we have to investigate the prime suspect behind our incorrect guesses: our own natural thought process. The reason this trips us up isn't really about the math at first, it's actually a psychological trick happening right under our noses.
Now, what's really interesting about this slide is the contrast between what our brain naturally does and what the math is actually doing. See, our brains are kind of selfish. They place you right at the center. Unconsciously, you're asking, what are the odds someone in this room shares my birthday? But the paradox doesn't care about your specific birthday at all. It's asking about the odds of any two people sharing any birthday. And that tiny shift in perspective, it changes the whole shebang. Now, I want to reassure you, your intuition isn't stupid. Not at all. If you look at it from that egocentric perspective, your instincts are spot on. The odds of someone having your exact birthday are 1 in 365. So if you're only checking 22 other people in that room against your own specific personal date, yeah, the chances of finding your personal birthday twin are indeed very, very low. But to solve this, we really need a paradigm shift. We have to stop looking at isolated individuals and start looking at the network of connections between them. If we really want to grasp the geometry of this coincidence, we aren't counting people anymore. We are counting the relationships, the possible pairs between all those people. Watch how this network actually grows. It's fascinating. If you just have two people in a room, there's only one possible pair, right? Simple enough. But add a third person, and suddenly you have 3 possible pairs. Add a fourth person, and you jump to 6 pairs. By adding just one person at a time, the number of connections doesn't just tick up by 1, it literally explodes. And this brilliantly illustrates the massive leap that happens here. By the time you reach just 23 people standing in that room, you aren't looking at 23 isolated individuals anymore. You are looking at 253 distinct pairs. Boom! Suddenly, the odds don't seem so crazy, do they? You actually have 253 different opportunities for a match across a 365-day calendar.
Now, figuring all this out perfectly without making our brains absolutely melt from counting all those pairs, well, mathematicians use a clever trick for that. Instead of calculating the messy odds of people sharing a birthday, they calculate the exact opposite. They figure out the probability of 0 shared birthdays, meaning the odds that every single person in that room is completely unique.
Let's walk through the math together. The very first person you ask has a 100% chance of having a unique birthday in that empty room, obviously. But the second person, they only have a 364 out of 365 chance of having a different birthday from the first. The third person drops to 363, and so on. As you multiply these fractions straight down the line of all 23 people, the chance of everyone remaining completely unique just steadily drops and drops. And because that probability of total uniqueness drops below 50% exactly at the 23rd person, the inverse becomes true. The chance of a shared birthday mathematically crosses that 50% threshold. So the math essentially guarantees that it's more likely than not that a birthday collision is going to happen.
Let's move to and see how this builds, because it is wild how incredibly fast this exponential math scales up to near absolute certainty. At 23 people, we're at that 50-50 coin flip mark. But just look at what happens when you put 70 people in a room. The odds of 2 people sharing a birthday aren't just high, they are 99.9%, with just 70 people, almost guaranteed.
So the crucial point is that the birthday paradox isn't actually a paradox at all. Not really. It's a perfectly sound mathematical reality. It only feels like a paradox because human beings, well, we evolved to think in straight linear terms. We are linear brains living in a universe that operates on compounding exponential scales. Our minds just simply aren't wired to instantly comprehend nonlinear growth.
Which brings us to a final thought for you to ponder today. Have you ever met someone with your exact same birthday in a totally random place? Or, witnessed this apparent paradox in real life? The next time it happens, or the next time you're just standing in a room with a couple dozen people, remember the hidden math of our universe that's constantly at play. It's not magic, it's just exponential probability. Thanks so much for joining me for this explainer, and keep questioning your intuition.